These are the test corrections for Unit 1, Logic and Reasoning. Question 1. Consider the following statements. Here we go. P, 100 is a perfect square. Q, 100 is not an integer. Write the statement below using logic notation. So we have to match the pieces of the given statement to the P and the Q that were given to us in the directions. All right, so it says 100 is a perfect square. That matches with P. And is the symbol. It looks like a capital A without the mark through the middle. A for and. Then we have 100 is an integer. That mostly matches with Q, but the original Q had a not. This no longer has a not. That means this portion of our sentence is negated Q. So we're looking for the multiple choice answer. There we go. We're looking for the multiple choice answer that is P and negated Q, and that would be answer choice B. Number 2, consider the following statements. P, the sum of two angles is 180. Q, the two angles are supplements. Which of the following is a symbolic representation of this statement? So we're going to take this statement that they give us and we're going to change it into logic symbols. All right, it says if. If, then has an arrow in the middle. Now we have to match the other two pieces of this statement with the given P and the given Q. All right, it says two angles are not supplements. That mostly matches the Q, except they added in the word not. That means this part is negated Q. The other part of this statement says the sum of the two angles is not 180. That mostly matches with P, except they have inserted the word not. It wasn't there originally. So this would be negated P. So we're looking for the multiple choice answer that says negated Q, arrow, negated P. And that would be answer choice D. Number 3, fill in the boxes with the correct symbols. Let P represent angle 1 is a right angle. Let Q represent angle 2 is not an obtuse angle. The first statement says angle 1 is a right angle. That mostly matches P. And if upon further inspection, like look at it closer, it perfectly matches P. Angle 1 is a right angle. That would be P. Now we have to figure out what symbol to put for if and only if. There are two ifs here, so I need the arrow that has two arrowheads on it. And then the last part of the statement says angle 2 is not an obtuse angle. That matches perfectly with Q, which says angle 2 is not an obtuse angle. So we're going to fill in P double arrow Q. And that's down here as one of our options. So we would drag and drop P double arrow Q. Second statement, angle 1 is not a right angle. That mostly matches the original P, except they've put a not in there where there was not one originally. So this would be negated P. The symbol for and, we just did that one in a previous question. That would be the upside down. Looks almost like a capital A. The final part of this statement, angle 2 is not an obtuse angle that perfectly matches Q. So we're looking for negated P and Q. And I see that here. That would be option 3. You would drag and drop option 3. But y'all, we can't do that, so we're just going to write it in. Negated P and Q. And the last statement says, therefore, that would be the 3 dots. Angle 1 is a right angle that perfectly matches P, or is the symbol V. Angle 2 is an obtuse angle, mostly matches Q, except Q originally had the knot in it. They removed it for this statement, so that would be negated Q. All right, let's make sure that option is down here for us to choose, and it would be option number 6. So we would drag and drop, or for your test corrections, just write it in P, therefore, P or negated Q. Question 4. What is the relationship between the two statements below? If you can bake cookies, then you can bake lasagna. If you can bake lasagna, that's just the end part switched to the front. Then you can bake cookies, that's just the original beginning part switched to the end. Nothing was negated, they were only switched. When you switch, that would be converse. So the relationship between these two statements would be A, converse. Number 6, what is the relationship between the two statements below? Statement 1, if it snows, then Rebecca will sleep in. Statement 2, if it does not snow, look, that stayed in the first part of the sentence, but it was negated. Then Rebecca will not sleep in. That stayed at the end, but it was negated. So they stayed in order, but each one was negated. That would be inverse. That would be answer choice C. Question 6, what is the relationship between the two statements below? Statement 1, if you put up your calculator, came first, then it will not get lost. It will not get lost is your conclusion because it came after then. Statement 2, let's compare. It starts off, if you do not put up your calculator, that matches with the original part, but it was negated. Then it will not get lost. That matches with the end, but it stayed the same. You can't negate just one part and not the other. So this one would be none of these. All right, number 7, which of the following represents the contrapositive of the statement? So for contrapositive, we have to switch and negate both P and Q. All right, so let's read it to begin with. If the sun does not shine today, that would be P. Then we will sit on the deck. That would be Q. All right, so we have to find where this one was switched and negated. So we have to switch them, and we have to negate each part. All right, this originally had a not in it. If you negate a not, it just simply goes away. The original conclusion said we will sit on the bench. We need to add the word not in there to negate it, since there wasn't a not there originally. So we're looking for it to say we will not sit on the deck. I don't quite know where to put that. Okay, so we're looking for if we will not sit on the deck, then the sun does shine today. Okay, we switched and negated each part. All right, so let's find that in our multiple choice. And I see that down here. I do believe in D. Let's double check it. If we will not sit on the deck, then the sun does shine today. Okay, number 8. Assume these statements are true. All geometry students do constructions. If you do constructions, then you will need a compass. Which of the following is a valid conclusion? Okay, so we learned in class that all works like if. So this sentence here can be rewritten as if you are a geometry student, then you do constructions. Okay, don't know what happened there. And again, what in the world? It's okay, maybe that's too close to the end. Okay, so I've rewritten that in if-then form. Geometry student is P, the hypothesis. You do constructions is Q, the conclusion. All right, the second sentence says, if you do constructions, that repeats Q, the conclusion. Then you need a compass. You need a compass would be a brand new R. So if we label everything, we have P, Q, then down here we have Q, R. The Q's are going to cancel each other out. So what we have left is if you are a geometry student, then you need a compass. All right, let's see if we can find that in our multiple choice. Y'all, that's B. They've changed it from if then to just geometry students need a compass. And that's okay. We can write it either way. We can write it if or all. And y'all, for this one, the all is implied. All right, next. Assume these statements are true. If a figure is a square, then it is a quadrilateral. The P, the hypothesis would be, is a square. And the conclusion would be Q, it is a quadrilateral. Okay, the next statement says figure A is a quadrilateral. That matches with Q, is a quadrilateral. Y'all, there is no law of deductive reasoning that goes PQ and then Q. So this one has no valid conclusion. So that answer would be D. Okay, come on. All right, number 10. Assuming these statements are true, if a person lives in Mechanicsville, then she lives in Virginia. Brendan lives in Mechanicsville. Which of the following is a valid conclusion? So we're going to mark that a person lives in Mechanicsville is P, the hypothesis. She lives in Virginia is going to be Q, the conclusion. The second statement matches up with lives in Mechanicsville. That would be P. We do have a law, it's called detachment, that goes if P, then Q, then you're given a piece of information about P. Your answer is going to be Q. So we're looking for one that says Brendan, because that's who we're talking about, lives in Virginia. Brendan lives in Virginia would be C. All right, number 11 says write the biconditional of the following statement in words and represent it using logic symbols. If you submit your homework, then you will get a homework grade. So P, the hypothesis, would be you submit your homework. Q would be you get a homework grade. In words, the biconditional would say you submit your homework. If and only if you will get a homework grade. To write a biconditional, you go into the original statement and you cross out if, you cross out then, and you put if and only if in the middle. Now, we can't forget to do the second part. Look, we've written it in words. Now we have to write it in logic symbols. For logic symbols, you would keep the hypothesis first or second. Y'all, this biconditionals can go either way. I usually just leave it the way it is. Okay, so I'm going to put down the P first. Now for biconditional, we have to have the two arrows. Okay, and then we just have the Q. It would have been equally correct to say Q double arrow P. Okay, either one of these are correct. All right, number 12. Consider the following statements represented by P and Q. P, Joe lives in Old Church. Q, Joe loves Chipotle. Write the converse of the following statement in symbolic form. If Joe does not love Chipotle, that would be Q, except it was negated. So the original statement in symbols starts off with negated Q. Okay. If, then is the arrow. He lives in Old Church matches up with P perfectly. He lives in Old Church. He lives in Old Church. But they don't want the original statement in symbols. They want the converse. For the converse, we're going to switch what we have. That's all we're going to do, just switch it. So the converse and the final answer for this question would be P arrow negated Q. Right, and I think I skipped one. I did. All right, number 13. Consider the following statements represented by P and Q. P, Sue brushes her teeth. Q, Sue does not have cavities. Write the contrapositive of the following statement in symbolic form. If Sue does not brush her teeth, then she has cavities. If, then would be the arrow. Sue brushes her teeth is P. This one says Sue does not brush her teeth. So that would be negated P. So what we're going to do first is write the original in symbols. And so far we have negated P. We have our arrow. Sue has cavities mostly matches up with Q, except it was negated because it originally had a knot. And down here, they took it out. So the original statement says negated P, arrow, negated Q. For the contrapositive, we have to switch and negate this notation. So switch and negate, and we would end up with regular Q, arrow, regular P. And that would be your final answer. Okay, question number 14 says, consider the following statements. P, perpendicular lines intersect to form 4 right angles. Q, vertical angles are congruent. R, 14 is not a prime number. Write a compound statement in words for the disjunction. A lot of people asked about all these words when you were taking your test. Y'all, compound statement is an English phrase. It means it's a statement that's made of more than one part. And disjunction just means that we're using or. Okay, so all we really have to do is write the words for these symbols. All right, so we have to take out the letter Q and write it with the words that Q represents. So we would say vertical angles are congruent. Now we need to know that the symbol V stands for or. And then we have to negate the R. So we have to take the R and negate it. Since there's already a knot there, we're going to take it out to negate it. So to finish our statement, it would say, or 14 is a prime number. All right, number 15, which is a counterexample to the statement below. If it is a berry would be P, our hypothesis. Then it is red would be Q, our conclusion. So to be a counterexample, you have to prove us wrong. So we have to find the object that is a berry, but it's not red. All right, so it has to be a berry. We got a blueberry. Blue is not red. So that would be the most obvious counterexample. But several of you wrote and told us correctly that a banana is also a berry. Yellow is not red, so you could have also chosen C, a yellow banana. You got credit whether you chose the blueberry or the yellow banana. I'm going to go with blueberry because it specifically says that it's a berry. All right, now for the next question, we have to explain our reasoning for what we just did. And I was trying to get it so we could see. Oh, there it is. Okay. So we could see the last question and where we have to write our explanation. All right, so I'm going to start off by saying, for a counterexample, the hypothesis has to be true. And the conclusion has to be false. And y'all, I should have put the conclusion as Q. Okay? Because remember, for a counterexample, we're trying to prove me wrong. That's why the conclusion has to be false. So whatever we choose, our answer has to be a berry that is not red. Because the conclusion has to be false. So you have to negate it. It has to be not red and a berry. Okay, you had to get in there that it had to be a berry that is not red to get full credit for this question. All right, number 17. Okay, choose the counterexample for the following statement. If x is a whole number, so x has to be a whole number, then x squared is greater than x. Okay, so let's get rid of our answers that can't work because it has to be a whole number. Okay, whole numbers start with 0 and then they're whole. So it'd be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so on and so on. So let's eliminate any answers that are not in the list 0, 1, 2, 3, 4, 5, 6, 7, and on and on and on. Okay, negative numbers are not included in the whole number group. So let's get rid of A. Fractions are not whole numbers, so let's get rid of B. 0 is the very first whole number, and if we continued our list, we would get to 12, so 12 is an option for a whole number. Now, the conclusion has to be false. That means that x squared cannot be greater than x. Okay, so that's the hard part for this one. It cannot be true. So x squared cannot be greater than x. That means it either has to be equal to or less than to be our counter example. All right, so we got to take this 0 and we've got to plug it in. 0 squared is greater than 0. X squared, x is 0. And x, y'all, you just plug that 0 in. And then you work it out. 0 squared is 0. And then 0 is just 0. Is 0 greater than 0? No, it is not. It's equal to. So, since this is proving the conclusion false, this is their counterexample. Remember, you're trying to prove it false. Let's just make sure that 12 doesn't work as well. All right, so take that 12 and plug it in. Is 12 squared greater than 12? Well, 12 squared is 144, and 144 is greater than 12. So this would be true. That wouldn't make a counterexample. Counterexample is to prove me wrong. I'm sorry, y'all. Prove me wrong. The only one that does that is C, x equals 0. Question 18 says, use symbols to represent the relationship between the sets. So if we look at this, we notice that they colored all of set A, the whole thing, everything in set A. They also colored everything in set C. When you color everything, when you include it all, that would be A union C, because union means everything, include it all. Okay, so A union C. All right, let's see what we have next. All right, so for this one, we have to shade A union B and not C. All right, so I'm going to draw a new diagram over here. I think that would be the easiest way. Here is set A. Here's set B. And here is set C. So we need to begin by shading all of A, all of B, and y'all, for union, we keep it all. If it got colored, we keep it all. Okay, so we've done that. Now we have to go back in and we have to shade everything that is not in C. So not in C. Look, that's going to be my pink. Not in C. You can't color inside of circle C at all. All right, so I think I have done that pretty well. Now, intersect means only where they overlap. So we have to see where the pink overlaps with the yellow, overlaps with the purple. And it would definitely be here, and here, and here. So the correct answer would be B. Okay, number 20. Use the given conditional statement to fill in the Venn diagram below. If it snows 7 inches on Monday, then school will be canceled. It snows 7 inches on Monday is P, the hypothesis. School will be canceled is Q, the conclusion. If, then would be the arrow. We learned that a different way to write an if-then statement would be to use all. Okay, and we want to put the hypothesis P in the little circle and the conclusion Q in the big circle. So what we would want to do here is we would want to put snows 7 inches on Monday. In the little circle, because that's P, the hypothesis. School will be canceled and the larger circle because that's Q, the conclusion. This Venn diagram over here means if P, then Q. All right, now number 11 says refer back to the previous question and remember we put P, the hypothesis, in the little circle, and we put Q, the conclusion, in the big circle. So snow's 7 inches was in the little, and canceling school goes in the larger circle because it's Q. Okay, so now what we have to do is explain the relationship between the two options to focus on why we put Q, canceling school, out here in the bigger circle. Why did we do that? Well, y'all, the first reason is just simply because it's the rule. Okay, for all Venn diagrams, like I don't mean all of them, y'all. I mean the ones that are all like if then. When the circles look like this, all P's are Q's. Okay, so for the Venn diagrams that show the relationship all, the hypothesis P goes in the small circle, and the conclusion Q goes in the larger circle. And then we really wanted you to elaborate on this thought. Why should Q go in the larger circle? And the reason is there are a lot of other reasons for school to be canceled. Y'all, school could be canceled because of water issues. School could be canceled because it's a holiday. Okay, there are lots of other reasons that school could be canceled. That's why canceling school needs to be the bigger circle to hold all of those other subsets that would happen when you cancel school. So you needed to continue talking about real life. There are many other reasons to cancel school. In addition to snow. In fact, in addition to snowing 7 inches. All right, let's see what we have now. All right, students at an athletic camp were asked if they play on their school's team for basketball, field hockey, or lacrosse. The results are shown in the Venn diagram to the right. We have to choose all the true statements about this data. All right, the first one says 3 students play field hockey. So let's color in the field hockey set. And I see that I've colored over the number 3 and 5. So actually, it should have been 8 students play field hockey. Okay, so we do not want to choose A because that is false. B says 15 students play field hockey, baseball, and lacrosse. All right, so let's take a look. Here's field hockey. Here's basketball, and here's lacrosse. All right, and means where they overlap. Okay, these circles do not overlap at all. So there are no students at all that play field hockey, basketball, and lacrosse. This would be false because those circles do not intersect or overlap. All right, let's see. C, 7 students play more than one of the listed sports. All right, the people here play basketball and field hockey. That would be more than one. Okay, the students out here play basketball and lacrosse. That would also be more than one. If you add those two numbers up, 5 plus 2 does give you 7. So C is true. You would want to choose that as one of the true statements. D, 38 students responded to the question. All right, well, you would just add all the numbers in the Venn diagram and see if it's 38. So we're going to add 3 plus 5 plus 6 plus 2 plus 7 plus 15. All right, let's see, that would be 8 and 8 and 22. If you add those up, you do get 38. D is a true statement, so you want to choose that one. All right, and 16 students played exactly one of the listed sports. These 3 people right here only play field hockey. That would be exactly 1. So we want to include 3. These 6 students out here only play basketball. So we want to include the 6. These 7 students out here only play lacrosse. That's only 1. So we want to include those. If we add these 3 numbers up, we get 16. E is also a true statement. So you wanted to choose C, D, and E for this question. Okay, number 23. Consider the biconditional below. An angle is acute if and only if the angle measures 45 degrees. All right, so for a biconditional, this statement can be read 2 different directions. If acute, then 45 degrees. Okay, it can be read backwards. If 45 degrees, then the angle is acute. All right, so if an angle is acute, that definition means less than 90 degrees. There are a lot of other numbers that are less than 90 degrees, not just 45. So this part of the biconditional statement is false. Now we have to come up with another angle measure that's less than 90 that isn't 45. Remember, we're looking for a counter example. So we just have to pick another number that's less than 90 that isn't 45. All right, and I see that C down here has the biconditional is invalid because 60 degrees is an acute angle and 60 is not 45. Therefore, that would be a counter example. And y'all, it's a counter example for the first part of the biconditional. We didn't even need to check out the second part because we already knew it was false. But let's look at the second one just to look at it. All right, if the angle measures 45, then it's acute. Y'all, that's true. The definition is acute is less than 90. 45 is less than 90. So this part of the biconditional down here is true. But for a biconditional to be overall true, both of these would have to be true. Okay, so we have to say the biconditional is invalid because this first one didn't work out, and our counterexample was 60. Okay, and our last question on this test. Okay, so it says, assume these propositions are true. All athletes are in good shape. Lillian is not in good shape. Okay, so let's look first at our laws. Okay, if you are an athlete, oh, y'all, I spelled that wrong. If you are an athlete, then you are in good shape. Okay, the second statement says Lillian is not in good shape. All right, so we're going to go back and label our P's and our Q's. P would be athlete. Q would be in good shape. The second statement says Lillian is not in good shape. That would be negated Q. Our law of contrapositive does say if P then Q, negated Q, therefore negated P. So the first valid conclusion for this set of statements would be Lillian is not P. She's not an athlete. All right, so let's find that. That would be B. The other thing that you have to remember is that if this original statement is true, then the contrapositive is also going to be true. Y'all, both of these true statements we're talking about come from the contrapositive. Okay, to write the contrapositive of a statement, you switch and negate it. So we're going to take this statement up here, we're going to switch it, and we're going to negate it. So that would be if you are not in good shape, then you are not an athlete. Let's see if we can find that in our list of options. It's not C. It's not A. This one says if you're in good shape, we're looking for the contrapositive where we negate it. So it's not D. If you're not in good shape, then you're not an athlete. The other correct answer would be E. Okay, once again, both of these answers came from using the contrapositive because the contrapositive is equally true as the original statement. All right, that is the end of the test corrections for Unit 1. Please let me know if you have any questions about any of the explanations, and I'll be glad to help you.